Good morning, everyone. I hope you're all doing well. I know I am. Although it's been an interesting morning this morning. I've had some, interesting developments, but I'll get to that in a sec. So this week, the majority of the work that I've been doing is continuing on the GUI, as you might have imagined from the thumbnail and the title of this stream. And I think it's going really well. I have realized that there are some things that I should be doing before I try to get the robot to juggle, and this week I've been implementing some of those things, and hopefully by the end of this stream you will agree that these things are very valuable things and will actually be super helpful as we move forward. So let's get into it. What am I clicked on right now? Cool. So the first thing that I'm kind of debating if I should show you a demo of the, let's show you a demo first. Let's do that. So here I've also added a new juggle cam. So you can see there's a camera down here for Jugglebot, which I think is kind of neat. It should be very helpful for showing all this stuff off as we are now. I'm not going to turn the robot on now for a reason I will get to in a sec. But I just want to show you what the GUI looks like now. So once the robot has been homed and everything else, you can see it on here. And this is the same as what we had before, except there's this slight difference of the centroid in the middle. Let me just rearrange my views so that I can see what you guys can see. So we can see the centroid in the middle here, this little purple cube with the purple arrow sticking out of it. And this is showing the position of the robot. So as I move it around, that purple arrow aligns with where the robot is pointing, which itself is like, yeah, cool, all right, that's neat. But when we combine it with the pattern view of the same sort of thing, we can now see exactly where the robot will be moving once I activate that pattern and where it will be oriented as well. So the circle part is, like if I actually just turn this on, we can see that the circle part is where the centroid follows and the arrows are where it's going to be pointing, which is super helpful. You may have also noticed this new drop-down menu is new, so I can choose what I want to see in the simulation at any time. Actually, that purple arrow should be turning off when I turn off the centroid as well. I've got to fix that. But yeah, I can turn everything on and off, including the workspace of the robot. So now I can see relatively easily where the robot can actually access. And this is really nice when used in combination with the jogging feature to just kind of like move it around. And I can make sure that it stays within the bounds that it's supposed to stay in, which is very nice. Another really, really useful thing is that the UI is actually taking the information of where the robot should be at an earlier stage. It's like it's upstream of when we truncate all of the leg lengths to make sure that the robot doesn't just break itself, which means that if you just extend the robot really far out to the side, it gets too long. And we can see these 4 red legs are now indicating that they're too long. And in a similar vein, if they get too short, they turn blue. So now I can really easily see which legs are overextended, which legs are overcontracted, and it's super, super easy. So I want to spend the majority of the rest of the stream looking at how I've implemented this, and then I want to show some problems that I just discovered about 15 minutes ago, which are not ideal ones. It's a continuation from last week. I think something funny is going on with the CAN bus. But anyway, we will get there soon. All right. God, there's so many bloody menus. So the first thing is giving color to Jugglebot's legs. And this was making sure that this is what I just showed with like how if it's overextended or overcontracted, they will change colors. And this was not super easy to implement because the information is coming from multiple places in the roles network. And that made synchronizing this information a little bit tricky because just to give some background to this, I really need to know when these positions are impossible because previously in the simulation just looked fine. Like I would get console errors saying like, oh, leg whatever is too long or too short, but those are kind of hard to keep track of, especially when many of them happen in quick succession. Like if it's doing the pattern and the entire pattern is impossible, then it's really hard to tell when, like what specific part is making the legs be too short or too long. And yeah, it's just really hard to see that. But showing it visually in the colors makes it so much easier. So my first thought was that I can subscribe to the leg lengths topic, which is the actual leg lengths that are getting published to the robot, and then I can compare those against what the simulation is calculating for the distance between the equivalent points. And that very, very almost worked, but I was always one data point off, and I could not figure out why this was happening. And yeah, it just became really difficult to synchronize these two sets of data, because one was from one part of the ROS network, one was from another part. They were both publishing as quickly as they could, but they weren't publishing at the exact same time. And so getting those to be synchronized was really tricky. Like if I got this one and then I got the next frame of this one, then of course they're going to be different because they're at different times. So yeah, that was not really working. I couldn't reconcile those. So my solution was to just make a new topic. And this may be a big foreshadowing for the issues that I'm having right now, but it works, at least for this purpose, it works. And so this topic is called leg state topic, where it just publishes from the same point as the leg lengths topic. So after the legs have been cut and their lengths have made, and once we're sure that the legs will not kill themselves, essentially on the actual robot, then it will publish out which legs are fine and which legs had to be clipped. And for any of the legs that had to be clipped, we're indicating which direction they had to be clipped. So if it's a -1, it's over-contracted. If it's 0, then it's good, it's within the bounds. And if it's +1, then it's overextended. And so this topic is just 6 values ranging from -1 to 1. And the coloring in the graph, in the 3D scene that I just showed, is based on these values. And this works really well. There's no synchronizing needed. There's nothing. It's just one data stream, and yeah, change the color based on that. So that's good. And I'm really happy with how that's working. It's very, very, very nice to be able to see visually exactly when things are going wrong and how they're going wrong. This is a big improvement. It would be good as well if I could make it so that the 3D scene showed where the actual robot will be. So if I showed like the current version with like high opacity and then like a translucent version of like where the robot will actually be with the clipped legs applied. But I don't think it's super necessary, and that might be a bit tricky. We'll see. But yeah, I've no immediate plans to implement that right now. So next thing was to show the workspace in the plot. And just to reiterate, that's this like translucent blue space in here. So this is where the robot can actually be. This is where the centroid of the robot can be, because it seems like a really small volume when you compare it to the size of the actual robot, but if you think about it just being the centroid, then it's actually a pretty big space. Like you can go all, this is introducing a problem that I'll mention in just a sec, but you can go like all the way out to the side, which is pretty far over. Yeah, it's really nice being able to see that. And my main intention for doing this is so that once I put in the actual juggling patterns, I'll be able to see the patterns. I won't even need to move the robot. I'll just see the pattern inside this workspace and go, yeah, that fits, or nah, that doesn't fit, and change it accordingly, which should be handy. And yeah, so how did I actually do this? Well, if I can get back on my PowerPoint. The best way that I'm familiar with right now to actually figure out the workspace at all is just brute force. So I generate lots of points. In the case of the actual workspace that I just showed, the total number of points in this full simulation was 100 million, which is quite a few. It took a good little while to run that on my computer. And simulate the robot at each point, and then check that the leg lengths are valid at that point. And if they are, then great, then they're good. And if they're not valid, then it's an invalid point. And what that ends up spitting out is something that looks like this, where we have, let me make this a bit bigger. Oops, that's way too big. I didn't even know that was possible. Yeah, so we have a plot that looks like this. This isn't showing all of the points that were generated. This is only showing the points that are so-called reachable. So imagine like an enormous, maybe not enormous, but a large cube of points all around this that are invalid. And just for reference as well, this was run with, I think, 10,000 points in total, compared to the 100 million of the actual final one. And so we can see this workspace here. This is where the robot can go, and it's happy. However, big asterisk is that this is only where the robot can go and be happy if it is at a neutral orientation. Once it starts rotating, things get a bit weird, and I'm not really sure how to, I know how to simulate that as a brute force way. It would be enormously complicated to run and would take a very, very, very long time. But I don't even know how to visualize that. Like if you can be in a position in many orientations, but not some orientations, how do you show that? I don't know. So this is everything about the workspace that I'm going to show is only in a neutral position, which is a bit of a limitation of it, but Jugglebot shouldn't be rotating too far in any given direction anyway, so it should be more or less correct. But yeah, so we've got basically a shitload of points here, and I need to figure out how to get these I needed to figure out how to get these into the 3D scene. And I don't want to just clutter my scene with like a shitload of points. I want to have it be nice and neat. And as you saw, I think that the end result is fairly neat. So the first step was to convert it into a convex hull. And that looks like this. Again, this is only with like 10,000 points in total for the full simulation. So here, I mean, I don't know what, there's like a couple hundred here maybe. And what this convex hull is basically, if you like cling wrap around this green shape, what you would end up getting is this convex hull, which does miss a lot of information. And as you saw before, when I was moving the simulated robot around, there was a point there where it was in the valid workspace, but some of the legs were too short from memory, and that shouldn't be happening. And it's only happening because at the very bottom of this workspace, it's really, really hard to visualize it. But it kind of like, if I can draw it on the PowerPoint, it kind of follows, this sort of shape. If you imagine that kind of like rotated all the way around, it's a little bit hard to see. But the convex hull doesn't capture that. It's just flat on the bottom. And I don't know of a better way to do this. If you are familiar with any better way to turn this sort of shape into, I want like the full outside surface. I want the full surface of it, but I don't know how to do that. So for now, I've just been taking the convex hull, and that's more or less correct. And once we've converted it into a convex hull, we can save it as a JSON and then import that into Three.js. And that ends up giving us this workspace that I showed before, which I think looks quite nice. And I'm really surprised at how quickly this renders and how it doesn't limit it doesn't make this web page much slower at all rendering this, because this is like a 700 kilobyte file just for the workspace, but it works. So I'm not really concerned about optimizing that any further. Let me put my windows back. Cool. So that shows me where Jugglebot can go, insofar as the workspace, but I also need to know where Jugglebot will go. So where will the paths that I send to Jugglebot take it? Because I need to make sure that these paths stay within that workspace. I could do this programmatically and have it say like, oh, this pattern that you have given it is outside the workspace, but I don't really know how to do that. And I feel like a visual indicator is still useful, even if I do have that program function as well. So I'm giving Jugglebot paths to follow. And right now, same as last week, the only path that's actually easily accessible, let's say, is that cone one, where it kind of like works its way around a cone. And I need to know if these paths will ever break the robot. The way that I've currently set things up, there are 3 paths. There's the current path, the next path, and the transition path that takes us from the current to the next. And the way that I have implemented this is I've done it in a very deliberate way because you may remember from, I think 2 weeks ago, I mentioned having a memory leak in my app, which meant that every 15 minutes or so, I'd have to like refresh the app. Otherwise it would get too big and then the web page would crash, which was really annoying. And I want to avoid having to make and delete Three.js elements every time I need a new element. I want to try to reuse elements as much as possible. And this was a little bit tricky with these paths because the paths have an uncertain amount of points in them, so an uncertain number of points. Some of them might be really short, some of them might be super long. I don't inherently know in advance how many points will be in the path. I could rearrange things in my path planning algorithms so that the number of points is always the same, but that feels kind of wrong to be doing that just for the sake of the UI. So what I've done instead is I use a spline object in Three.js. And what this allows me to do is I can keep the one spline object per path and just simply update all of the control points for that spline. So whenever I have a new path that has been made by my path planning algorithm, it publishes it to the paths topic, which is then read by the UI, and all of the control points for the relevant spline are updated based on that paths topic. And this means that there's no need to dispose of or remake any geometries at all. We're just simply updating the control points. So we always have one spline per path and it never changes. So this is good. I still have no more memory leaks and I'm very happy about that. That was a really annoying problem. So this is all fine for the position that the robot is going to follow in the path. So if we go back to the UI, this is showing, like everything that I just described is for the circle part of this. So this will show the position of the robot as it moves around, but not the orientation. And the orientation is arguably at least as important. And so I wanted to be able to display both. And also to understand why it's important, all of these paths need to be as smooth as possible. So the more information I can get about what is going on as the robot follows those paths, the better. Because this way, when I stitch multiple paths together, I'll be able to see if these arrows are smooth relative to each other, or if there's like a discontinuity somewhere. Because if there's a discontinuity, that means the robot is going to be trying to go from, say, here to here instantly, and that's not going to be very good. So position is one thing, orientation is the next thing along. So how do we do the orientation? As ChatGPT suggested, I am using the Three.js arrow helpers elements. And these are set to only appear every interval points, and that way we get this nice kind of spacing of them. I'm really hoping that this works out nicely to indicate the speed that the platform will be traveling at, because maybe that's a bit hard to explain. But yeah, I'll talk about that later, maybe. But yeah, right now the arrows are set to only appear every interval, and that way it's just not too cluttered, essentially. And yeah, quaternions are weird. But before I get to that, actually, I want to just describe how I did the same sort of thing as for the spline elements, where we only have one spline and we update the control points. Now with these arrows, there are a maximum of 500 arrows that I can add per path. And the way that these are set up is that they're in pools. And each pool is basically looked at, and we take as many arrows as we need from that pool according to the length of the path. And for all of the other arrows that are in that pool, we just set them to be invisible. So they're still there, they're still present. I don't really know where they would actually physically be. I guess just at the origin, maybe? I don't know. But they're all invisible, so we just ignore them. So they're there in the simulation. There's 1,500 arrows there. We just can't see them. And the whole thing still runs quick. So I don't know. This whole time I've been asking ChatGPT, like, how many of these things is actually bad? And it's like, oh, like, as long as you're less than like 2,000 or like 10,000 or whatever. And I'm like, oh, cool. Okay. I've got lots of headroom then. This is great. But yes, the trickiest thing about this was that quaternions are pretty damn weird. And to show you what I mean by this, if we look back at our GUI, and if I just change something real quick in how the arrows are displayed. This is what I was dealing with for so long. I had like everything was set up like this. Let me just refresh. Oh, what is? I really don't like this lag between YouTube and what I'm actually showing. Yeah, so this is all fine. It's like, oh, cool, yeah. The arrow is pointing up and the robot is up. This is nice. But then, oh, what the heck? I am so confused right now. All right, that shouldn't be working. That should be oriented. Oh, sorry, no, I grabbed the wrong one. Let me just, this is worth showing, I think, because it's so strange to like understand what's actually like going wrong here. Yeah, when it does stuff like this. So it's all good when it's up, but then as I tilt it, the arrow tilts in the wrong direction. And this means that when I have like the pattern, it's all wrong. And there's so many different ways of orienting everything here. Like we can do it like this, where I can put a negative here. And then really weird stuff happens. It took quite a long time to try to get these to match up correct and be what they're supposed to be. I don't know if that's super visible. But hopefully you can see that those arrows are very not doing what they're supposed to be doing. Yeah. The TLDR of why this was happening is that the 3JS scene uses a different convention than what I'm using for the robot. So I'm using Z is up and X and Y are perpendicular to that. And that just seems to mess with everything. Whereas, 3JS uses Y is up. So everything's rotated a little bit. But you would think that it's just a 90-degree rotation, but for some reason that doesn't work. I've got to like invert everything. And what ended up working is putting negatives. So for one thing, I have to swap. Normally this would be like X, Y. I'm not showing. Normally this would be X, Y, Z. But I've had to swap Z and Y because I believe that's because of the fact that I'm using Z up and they're using Y up. But then I also need to have these negatives out the front here. And I don't really know why, but it works. And so I'm happy with that. I do need to add in more different paths with like different sort of funky orientations and really strange movements just to verify that everything is actually working. But I've played around with it with the Space Mouse and I can move it everywhere where I seem to move it. It seems to be correct. So I think this is good now, but it's just so weird, I find. Anyway, cool. So I want to now give you a demo of the actual robot moving around, and I want to show you what I discovered about 20 minutes before this stream. So let me just fix my windows up. Even with this giant monitor, I still have to move everything around. Cool. So everything boots up fine, same as it always did. And what view would be best? Maybe this one. Yeah, it all turns on. Everything's happy with that. It's all good. I just need to quickly change some things around so that we have the CAN bus active. Yeah, this whole week all of my testing that I've been doing, I've had the CAN bus handler node off, which has meant that everything is just being run in simulation land, which is really helpful, but I've realized that there are some weird things that are going on. I touched on them last week, and I still don't really know what's actually happening here, but things are behaving strangely when I'm moving from sim land to robot land. So everything should be on now, so this can refresh. Cool. So everything's on. We should be able to home the robot. All is working well. And if we center it, yeah, same thing. I don't know what's going on here. One of the motors, motor 0, let me make this view a bit bigger. How do I can't even like draw it. The one on the far left here, it's just not turning on now. Well, sorry, it is turning on. It appears to be homing fine as far as I can tell. I've only been able to try this a couple times, but it isn't responding to anything. There's no errors in the, like from ODrive. Like if I run ODrive tool and check for errors, there's none. There's no errors reporting in my console up here. I don't know. It's very odd. It's very, very, very strange. My CAN bus, let's just double check. CAN bus is still up and running fine, but just that leg just doesn't seem to respond, even though it thinks that it is responding. I'm not sure. I only just discovered this earlier today. I've checked all the wiring, seems fine. I don't know. It's very weird. Let me just check ODrive tool again. Yeah, no errors. I don't know. It's weird. So part of me feels like the CAN bus problems, like right now the CAN bus is working fine. Everything is still reporting values. Previously, last week, when I mentioned the CAN bus problems, when the problems occurred, the bus wasn't even responding at all. Like if I would ask for a CAN dump, it would just wait and nothing would happen. But now the CAN bus is actually working. I think there's something related to the total load on the system. Like, maybe I'll show you my view. Just give me 1 second. I'll show you the Jetson view so you can see what I can see. For some reason, some of my startup scripts don't actually start on startup, which is a little bit frustrating. So we go to this, and then make this this. There you go. So you should be able to see the Jetson view now. Yeah, so the CAN bus is dumping. That's fine. But I think the issue is because I've got too many things going on. But like this computer, the Jetson Nano, is designed for robots. And I feel like what I'm doing right now is not that intense as far as robots go. So like I've added in the paths topic, which is publishing like a decent amount of data relatively regularly, but not like all the time. I don't know, maybe I need to look into the QoS stuff a bit more, because I haven't actually set up any of those QoS, like the quality of service parameters, I guess you'll call them. I haven't set any of those for anything, so maybe I just need to make the CAN bus handler like #1 top priority, and then everything else is kind of secondary to that. Maybe? I don't know. Yeah, so I've only added in the paths topic, and I've changed the robot plotter topic a smidgen, and also the leg state topic, this guy. 3 new topics, and things aren't working. I don't know. I think today I'm gonna have a bit of a play around with just disabling certain nodes and seeing if this problem is affected by that at all, or maybe even just going like really low level, just the CAN bus handler and like the space mouse handler or something, just to try to see if this problem is ROS related or something a bit lower level. I don't know. It's weird. It's only one motor, motor 0, if it matters that it's 0. I don't know. Yeah, things are weird. Things are very weird. Anyway, let's go back to this. So I've got some final thoughts on... I didn't do my animation properly for this. Final thoughts for what I'm going to be doing next. The first thing that I want to do is to integrate my code that I can use to take the current position, and I can tell the robot to move to a different position with a different velocity, and it will construct this Bezier curve that I've mentioned before between those 2 points, and that will maintain constant position and constant velocity. Well, sorry, not constant, but smooth position, smooth velocity between those two poses, if you will. If anyone knows the correct term for this as well, actually, this is another thing that I'm curious about. I've been using pose for position orientation, but what do you use for position velocity? Is that also pose? I don't know. State, maybe? Yeah. So I want to integrate that code. I would also, I'm thinking it might be useful to include a visualization of the velocity of the platform in the GUI. So like before, how I mentioned that having the position, so I'm just going to turn that off in case it's loud. I mentioned before that having the position showing is super helpful to make sure that the position is smooth. Similarly, showing the orientation that the platform is going to be in all different positions is very helpful to make sure that the orientation stays smooth even as I combine multiple paths together. And I think the next step along here is showing the velocity to make sure the velocity is smooth between all the different patterns that I show. But yeah, I think I'll have to do that after I do the first one. I think the first one is pretty important because that's how I'm actually going to be controlling Jugglebot to juggle. But I need to figure out some way to show this in the UI so that I can actually interact with this easily. I don't know, we'll see. And also there's going to be no stream next week because I'm going outdoor climbing for most of the week. So I won't really have too much to report on. Hopefully I'll be able to get a bit done today and like late next week. But yeah, I'll be gone Monday to Wednesday. So that's a huge part of the week out. So I'm not going to do a stream next week. There's also a stream in a couple of weeks I'm going to have to miss because we've got a planned power outage in our area. But I'll mention that when we get there. But yeah, so this will be the last one until, what, the 9th of January. And yeah, so very interesting developments. I think the UI is going fantastically. I'm really, really, really happy with how that's looking. But I don't know what's causing these issues with the robot. I am starting to appreciate when robot people talk about how hard making robots is. Yeah, there's a lot going on. And it's tricky to manage everything. Anyway, I will see you all in 2 weeks. And until then, I hope that you have a good one.